Today, ladies and gentlemen, we are going to learn how to factor quadratic equations. This is one of my favorite lessons that we do in the year, and we're going to finally be doing a lot of things that you've learned in the past and putting it all together. So we're going to be taking a quadratic equation. We are then going to be putting it into a diamond problem and then a generic rectangle in order to solve and find the roots for the equation. So it should be a lot of fun. So let's go ahead and start by just going over the basics of what a quadratic equation is. So our official title is Factoring Quadratic Equations. Okay, and we're going to go ahead and just do a brief overview of the parts of a parabola and what we're looking for. So we're just going to do a quick sketch with our x-axis and our y-axis. Okay. And we're going to go ahead and draw a parabola. We're going to make it a smooth curve. It's symmetrical on both sides. Okay, and we're going to name the different parts. So what we're looking at is this point right here, which is the lowest or the highest if it's an upside down parabola. This is called the vertex. This is called the vertex of your parabola. Okay. What we have right here is our y-intercept. And our y-intercept, of course, has a 0 for your x and a number for your y. It's where your parabola crosses the y-axis. Now, here and here, we have our x-intercepts. And it is where our parabola crosses the x-axis. And we know that our x-intercepts have a number for x and a 0 for y. However, there are a lot of names for our x-intercepts. They are also called our roots. They are also called our zeros. And they're also called our solution. So all of these x-intercepts, roots, zeros, solution are interchangeable. So when I ask you to find the roots, I could also ask you to find the zeros. I could also ask you to find the solution. Okay, and then our very last little spot here is a line that goes through the vertex and is vertical. And this is called the line of symmetry. The line of symmetry. And our line of symmetry is where we could fold it in half like a butterfly and it would match itself. So it has a line of symmetry. It crosses the x-axis, so it's an x equals line. So it's an x equals whatever the x value is of our vertex, and that's known as the line of symmetry. Okay, so we're going to go ahead and we're going to take an equation and we are going to use that to find the vertex and the roots and the y-intercept. So our equation is y is equal to x squared plus 4x minus 12. Okay, and what we're going to do is go ahead and find out as much information as we can about this. And we're going to be going through all of the steps to go from here and to factor it, which is to find the roots. So here is step number 1. You are going to make an x. Easy enough, right? And this, of course, is our diamond problem. And we are going to go ahead and do A equals B equals and C equals. So we're going to write that right next to it. And the format is A x squared plus bx plus c. So what that means is when I take and look at my equation, I look at my a, my b, and my c, my a is going to be the number in front of my x squared. My b is going to be my number in front of my x, including the sign to the left, and c is going to be my constant. So we take a look and see what's in front of our x squared, and there's nothing there. However, we know that if nothing is there, it's an invisible 1 because there's one x squared. So our a in this case is the number 1. We look at b, which is the number in front of our plane x, and we see that that's a positive 4, so that's going to be 4. And we look for c, that's our constant. Remember to include the sign to the left, and our c is negative 12. Okay, so now what we're going to do is we're going to take these numbers and we're going to put them in our top and bottom spots. So our top is going to be a times c, and our bottom is going to be b. B bottom, B bottom, B bottom, B bottom, B bottom. So I'm going to go ahead and I'm going to multiply a times c for that top number. So 1 times negative 12 is negative 12. And then we're going to take our b, and that's going to go on the bottom, b bottom, B bottom. So that's a 4 in this case. Okay, so that's how we take our equation and set up our diamond problem. Step number 2 is solve your diamond problem. So we're going to go ahead and find our right and lefts. So we had this notes a couple back. You might want to review that video and watch. But we take our 12 and we look at the factors. So we have 1 times 12 gets 12. And that adds up to a 13, subtracts to 11. We're looking for a 4. Next we have 2 times 6, which adds to an 8 and subtracts to a 4. Ding, 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 ding. That's what we're looking for. So we're going to put a 2 on one side and a 6 on the other. And then we want it to be positive 4. So 6 minus 2 is 4. Okay. Step number 3 is make your generic rectangle. So we're going to go ahead and make our generic rectangle, which of course is just a square, a line down the middle, a line up the side, 2 lines, 2 lines. Okay. Now, here we're going to use 2 different places. We're going to be filling the inside of our generic rectangle in. And what we put in this box down here is whatever your ax squared is from the top. And of course, that's just for me, a plain x squared. In the upper right, you're going to put your c, your constant, which in this case is negative 12. Now that's coming from our original equation there, our ax squared and our c. Now in these, we're going to put side x, side x. So these are the 2 numbers that we found from our diamond problem. So we're going to put negative 2 and then an x, and then we're going to put a 6 and then an x. Okay, so how we get our original information and fill it into our generic rectangle is really important. So you want to make sure that you understand that. We take from our original equation our x squared here. We put our constant in the upper right, and our other 2 sides, we put our answers from our diamond problem. Step number 4 is solve your generic rectangle. Okay, so we're now going to do what we learned last class, which is the reverse distributive property. Now, x squared, there's only one way to get x squared, and that's x times x. To get a 6x, we know x times 6. And then to get a negative 2x, we know that's x times negative 2. So we're going to go ahead and write these in product form. So we have x plus 6 times x minus 2. Okay, and so it is factored. And so we're taking our original problem and we're moving it into this format. Now, we want to go ahead and double check that work in Desmos. So the way that we double check that work in Desmos is we type in our original problem, y equals x squared plus 4x minus 12. Okay, and we see we have our parabola here. Okay, and then we type in our product form, our answer. We have x plus 6 times x minus 2. Now, if I had done this incorrectly, I would see two different parabolas. But I know that I got the answer right when the parabolas are right on top of each other, because once again, I'm just writing it in a different format. So now what we're going to do is we're going to find out what these roots are, and we're going to find out the vertex mathematically. So what we do next in order to do this is we use what's called the zero product property. And what that means is we want to find our zeros. We want to know when our x is a number and our y is equal to 0. So if I know that y is equal to these two, if I can make this set equal to 0, 0 times anything is 0. Or if I make this equal to 0, 0 times something is 0. Or if I can make them both 0, then that will also have them equal to 0 for my y value. So we want to find how many roots we have, and we want to find what those roots are. So by using this zero product property, all we're going to do is set each set of parentheses equal to 0. And then we're going to solve for x. So we're going to subtract 6 from both sides. And I have my first x is equal to negative 6. And then I'm going to solve for x for my other one. And x is equal to 2. So I have, at this point in time, my two spots. These are my x-intercepts. These are my roots. These are my zeros. These are my solution. So I know that I am going to have an x-intercept at negative 6 and an x-intercept is at positive 2 on this parabola. So I could write these also as ordered pairs. Just be careful. Make sure you give it in the form that I'm asking you. So if I'm asking you to give it to me as an ordered pair, you can give it to me as an ordered pair. If I ask you just as x equals or a plain number, you can give them to me in this way. So we have one more step that we can do with this parabola in order so we can graph it. And that is we need to find the vertex. Now, because we have our vertex right here, and we know that our vertex goes through the axis, the line of symmetry, we know that these two numbers are equidistant. So what we want to do is we want to find the middle of those two numbers. So we're going to add them together and divide by 2, and that's going to give us the x value of our vertex. So we're going to go negative 6 plus 2, and then we're going to divide it by 2. So that gives us negative 4 over 2. So we have an x value of negative 2. Now I know that the x is negative 2 for my vertex, but I need to find the y. So I can do two different places. I can plug in x here and here to solve for y, or I can go back to my original equation, and I'm going to get the same answer. I prefer to plug it into this because the math's a little bit easier. So here I have y is equal to negative 2 plus 6 times negative 2 minus 2. So that gives me y is equal to 4 times negative 4. So y is equal to 16. So I know that my vertex is going to be at 2, and that's a negative 16. So negative 2, negative 16 is going to be my vertex. Now, why would I want to do this? Well, this allows me, if I know my vertex and my two x's, I can go ahead and graph it. So here I have 1, 2, 3, 4, 5. 1, 2, 3, 4, -5. So I'm going to go ahead and count my 5s going this way. 5, 10, 15, -20. Okay, and I can go ahead and graph my intercepts. I have an intercept at -6, and I have an intercept at +2, and -2, -16 is my vertex. And I can go ahead and do a smooth curve, and now I have that parabola. Okay, and I always grade your point, not your curve itself, because I know the drawing part can be a little bit harder for some of us than others. So this is our overview of how to factor a quadratic using a diamond problem and a generic rectangle, then the zero product property, and finding the vertex as well. So we're going to be working on this a lot through the chapter. We're going to focus on different areas, but this is our overview of basically what we're going to be doing with different types of problems. Let's go ahead and jump into our Desmos activity and get some practice.